Today, we're going to look at how we can derive the quadratic formula that is really important in any level of mathematics in GCSE O level or the GCSE advanced level. So this is a really important formula. So most of the time you might be using this one, but sometime some of you may not know how to derive the formula. So then let's look at how we can derive the quadratic formula. So with some simple steps actually, right? It could be a quadratic equation like this. Or it could be a quadratic expressions like this. So in the first case, we have to solve this equation to determine the roots or the solution for this quadratic equation. In this case, we can factorize this the quadratic expression to determine the factors. We know that a quadratic could have two main shapes. Actually, one is N shape, or we call a maximum, or it could be a minimum. Actually, so this is normally determined based on the coefficient of the x square term, which is the a term here. If a is greater than 0, so we normally considered that is to be a minimum shape or the U shape. If the a is less than 0, that means it's a negative number. So then it's a maximum, right? So now we're going to look at how we can derive the quadratic formula starting from this equation or this expression, whatever you like. So then here we know the quadratic formula can be given as or the x equals to minus b plus or minus b squared minus 4ac over 2a, right? We know that, so this a, b, and c are some constants. So there could be some integers or some numbers. So there are some constants relating to the quadratic equation or the quadratic expression, right? So then how are we going to get this the quadratic formula? So starting from one of these the quadratic equations, like, so I'm going to just start with the quadratic equation, which is ax squared plus bx plus c equals to 0. We know that the completing square is one of the important the steps of the rearranging the quadratic expressions. So here I'm going to just look at that here. So then here I'm going to take this a out from the equation first of all to make the coefficient of x squared to be 1. So then we can get x squared. So then we get a b over ax and then plus c over a is equal to 0. So then we can start the completing square now. So we can keep the a outside here, and then we get the variable here, which is x, and then half of the coefficient of the x term, so which is b over 2a, and then the bracket, and then square to the whole thing, and then the third term as it is, which is c over a, and then always take away the square of this the term here, which is b over 2a squared, right? So I'm going to close the square bracket here and then equals to 0, right? So then afterwards, so then I'm do simple the algebraic simplifications. So we can just simplify this further. X plus b over 2a squared. I'm going to get the common denominator here after expanding the last term here, which is going to be b squared over 4a squared. Okay, that is equal to 0. So then after that, so then we can have the simplified term for the latter part of this. So we could get here multiplying both the numerator and denominator of this one by 4a. We can have the common denominator for those two terms. We could get 4ac. Then if you multiply a by 4a, it will become 4a squared. So then we can have the common denominator for these two terms here. Okay, so then it goes to 0. And then now I'm going to again do more simplifications. Right, so we can just add the terms in the numerator. So we can write a common denominator like this. Right, so then after this point now, I have to make some argument. So we know that when we solve this equation now, so we have two possible options here. Either it could be a is equal to 0, or the other term which is inside the square bracket now, which is x plus b over 2a squared plus 4ac minus b squared over 4a squared can be equal to 0. So these are the possible options if you want to solve this equation here. So which has two factors, right? So then the simple argument here, can we assume a to be 0? Right, so but simple, the answer is that, so a cannot be equal to 0. The reason is that we know the quadratic equation that we considered is this: x squared plus bx plus c is equal to 0. Okay, if a is equal to 0, then there is no quadratic expression. Then there is no quadratic expression. Or equation. Here a0 means the x squared term just disappears. So therefore, it is not a quadratic equation or term anymore. So therefore, we cannot consider a to be 0. So then only possibility would be that the other part, which is this part, should be equal to 0. Right? So then we can just carry on in that sense, then we can assume that, so the x plus b over 2a squared plus 4ac minus b squared over 4a squared should be equal to 0. So that is the possible solution for this particular situation. Right, so then again, the simple, the algebra. So we can move the sum terms into the right-hand side of this equal sign. So we could just move all the terms here to the other side. So then in that time, so it becomes negative. So then I'm going to switch the terms in the numerator. Then we don't need to write a negative in front of the expression here. Right, so it will become like this. I hope you understand what I'm doing here. So then after that now, so we want to get rid of this, square term. So if you want to get rid of the square term, what we normally do is that we just get the square root of the both side. So we consider square root of the both side of the equation. So then we get x plus b over 2a. So square term will disappear. So we know that when you get the square root, so then we try to get a plus or minus here. And then we can put b squared minus 4ac over 4a squared. And then we just put square root for the everything here. Right? So then go to the next step. So if you remember the normal rules of the surds, so we can just rewrite this by just having separate the square root signs for the numerator and denominator. Right, so then that is really simple algebra steps here. So then we could carry on x plus b over 2a is equal to plus or minus b squared minus 4ac. Then if you get the square root of the 4a squared, which I can write as 2a squared, then if you try to get the square root of this one, it will simply be just the 2a. And then, but still we have the square root on the top term on the numerator here, because we did not simplify it yet, right? So then what I can do, I can move this term into the right-hand side. So then it will become x is equal to minus b over 2a plus or minus b squared minus 4ac over 2a, but we have to keep this square root sign here, right? So then you can see that we have the same denominator, what we call a common denominator for both terms. So then we could write x is equal to minus b plus or minus b squared minus 4ac over all over 2a. So hope you can see here now we have the quadratic formula as a solution for this simple calculation that we did. This is what we called as the quadratic formula. So you have to use this in some of the GCSE ordinary level mathematics, and also this is useful in advanced level mathematics as well. If you look into this quadratic formula, so then here the b squared minus 4ac, the term is known as the discriminant. Right, okay, so but for this part is not related to the O-level students or ordinary level students. So we recognize b squared minus 4ac as the discriminant of the quadratic. Then we can decide the nature of the quadratic curve in terms of whether it is intersecting with the x-axis or not. Right, so then here if b squared minus 4ac is the greater than 0 mean, so that equation should have two distinct real solutions. So what that means, when we sketch it, it could be in a format of like this, or it could be a minimum, or it could be a maximum. So it will just intersect with the x-axis at two different locations. So that means we have two distinct real roots. Okay, so then if you consider this the discriminant to be equal to 0, so what that means, it has real solutions, but they are identical actually. Real but identical solutions. So that means you can factorize the quadratic the expression, or you can factorize the quadratic equation and solve it. So, but you will get the identical answers. So here what will happen is that, so when we sketch the quadratic graph, so it will only touch the x-axis, but it will not the cross the x-axis. So then it will be only a the touching point, or the x-axis would be a tangent to the quadratic curve actually. So if it is a maximum, so it could be something like this. So it's only touching the x-axis at a given point. So that means this has real but identical solutions. So then the third situation is that the discriminant, which is b squared minus 4ac, is less than 0. So then what will happen? So you will get negative inside the square root sign. So that means it is not defined. So then you can't solve it. So then we could say that no real solutions to that quadratic equation. The reason is that you have the quadratic formula. So then you will get something like this. It's minus b plus or minus. So this term would be negative. So that means you cannot just solve this at your level. So therefore you don't know how to solve this one. You have to go to the complex numbers. So here what will happen is that the quadratic graph will not intersect or touch the x-axis. So therefore it will be a situation like this. So if you sketch it, if it is a minimum curve, so it would be like this. Okay, if it is a maximum, it could be something like this. It will not touch the x-axis at all. So then that is the situation if the discriminant is less than 0. Hope you understand the situation now. So this is how we can just use the discriminant relating to the quadratic formula to determine the nature of the quadratic the graphs, to check whether it has the two distinct real solutions, or identical solutions, or no real solutions. Okay, then let's look at a simple example how we can just use the quadratic formula to solve a simple quadratic equation. So here we're going to look at the example. So let's say we want to solve this simple quadratic equation. So then I'm going to compare this quadratic the equation with this the basic quadratic format. So then we can recognize the A, B, and C relating to this particular equation actually. So as you can see, A is equal to 2, then the B is equal to -1, so C is equal to -3. Hope you can here notice that. So if you have a negative in front of these coefficients, you have to consider the negative sign as well, because here we have the positive signs, right? So then now we know the quadratic formula, which is x is equal to -b plus or minus b squared minus 4ac over 2a. So then now we can substitute these numbers into this particular equation. So x is equal to -b. So it's -1 plus or minus. So b squared means it's -1 squared minus 4. And then the a is equal to 2. And then c is equal to -3 here. I will write that inside the bracket here. So then all over 2 times 2. Right. So we try to simplify it further. -1 will become +1. So plus or minus. Inside the square root, we'll get now 1 minus 4 times 2 is -8. -8 times -3 is going to be +24. Right. So in the denominator, it will be 4 here, 2 times 2. Right. So then we can carry on. So x is equal to now 1 plus or minus 5 over 4. Right. So then we can separate the two solutions here. 1 plus 5 over 4, or x is equal to 1 minus 5 over 4. Right. So here we can see that. So it is equal to now 6 over 4, or so x is equal to -4 over 4. So that means x should be equal to 3 by 2, or x is equal to -1. Okay, right. So those are the two solutions relating to that particular quadratic equation. So which is x equals the 3 by 2, or the x equals -1. So otherwise we could say that here, so we can rewrite that quadratic equation, which was 2x squared minus x minus 3 is equal to 0. We can write this as so 2x minus 3 and x plus 1. Okay, so then we can just rewrite this as with two linear factors in this format. I hope you understand what I mean here. So if I solve this quadratic equation now, you will get two real solutions. These are the solutions here. X equals 3 by 2, x equals -1. Okay, so we can sketch this quadratic graph, but we can look at that later on. Okay, so then I hope you understand now how we just generate the quadratic the formula by starting from the basic quadratic equation, x squared plus bx plus c equals 0. And then after that, we looked at about the discriminant. By looking at the discriminant, we can decide how many solutions a given quadratic will have, and then whether they are real or non-real. Then I just showed you here how we can just use the quadratic formula to solve a quadratic equation. Hope it is clear. So then later we can look at how we can sketch a quadratic graph using some simple steps.